Hello, this is Jennifer Martinez. Today we're going to be going through the notebook on page 45, starting on page 45. This section is C1 on inequalities. What does an inequality mean? Well, let's look at this right here. This sign stands for less than. This means x is less than y. Let's look at an example of that before we go on. So what if we had something like x is less than 3? What does that mean? That means all the values of x that are less than 3, like 2, 1, but more than that. So what I'm going to do is I'm going to draw, like we did in exercise 1, a number line. A number line is like our x-axis. It's just one-dimensional because there's no y here. It's just x is less than 3. And what it is, I mean, obviously it goes on forever. The number line goes both ways. That's why I have two arrows here. But x is less than 3 are all the values, like I said, 2, 1, all the values. In fact, I'm just going to shade everything, even fractions like 2.5, everything but 3. This number line is a great visual because notice how 3 is not included. So I make it an open circle. Even 2.9, fractions, decimals, close to 3, but not 3. So these are all the values less than 3. The next one, with a line underneath, x means, it's right here on the right, it means x is less than or equal to y. That's what the second line means. Let's do an example. Well, what about x is less than or equal to 2? So what does that mean? All the values that are less than 2, like the 1 and the 0 and all the fractions in between, and also 2. So if we were to draw a number line, again, this would go on forever. It's like the x-axis, and it's even negatives, right? These are all things. I'm going to shade everything to the left, all the stuff less than 2, and also 2. So that's what that means versus the first one. The next one, x is greater than 3. What does that mean? That means, well, I already said it, didn't I? X is bigger than 3 is what that means. You will notice the arrow is pointed the other way. Kind of like, think of it a Pac-Man. If you make a little Pac-Man out of this, the mouth is always right hitting the bigger number. So this one's not hitting the x. That's why it's less than. And this one is. That's why it's greater than. The next one, x is greater or equal to 3 is what this one means. It's right there. So let's try their example. It says draw the solution set on a number line. Oh, so we now know how to do that. I'm going to do it in red. So again, I'm going to put 0 in the middle, and maybe this is my -3. Things that this is now bigger instead of smaller. So what is bigger? Right, bigger than -3. Well, believe it or not, -2. I'd rather be 2 in the hole than 3 in the hole. So -2, -1, all these values, and the positives, obviously, 1, 2, 3. So I'm just going to shade everything, and again, I'm going to put a solid circle just to indicate a notation to say that -3 is included. The last one, when you have two inequalities, they call this sometimes a compound inequality. This means y is in between the x and the z. And here's what they say, y is both greater than the x and less than the z. Well, this one makes sense. Y is less than z. But if you were to rewrite this, like on, let's do an example like that. If I was to rewrite this, x is less than or equal to 2, I would write, and I wanted to put the 2 on the other side, I would have had to say this, because if x is less than or equal to 2, that means 2 is greater or equal to x. It means the same thing. So that's why this is x is less than y. That means if you switch it around, right, that means y is greater than x. So y is greater than x and less than z. So here on this one, it's a t, but I'm just going to put my 0 in the middle. I don't feel like counting by 10, so maybe I'll count by 2's. Oops, there's my negative 10 is what we want there. That looks a little bit better. So I'm counting by 2. So this is negative 2, right? Negative 4, negative 6, negative 8, negative 10. And we have a negative 10 and we have a negative 2. And this means t is toddling in between them. It's less than negative 2, but it's bigger than negative 10. It's toddling in between. By the way, on this side, it's a strictly greater than, so I'm going to keep an open circle, but to signify that 2 is included, I'm going to make that one solid. So that's how you write it when toggling in between. If it's on the outer, you have to just write it as 2. If you have something on the left and the right. If you had 2 things on the left and the right, what we would write is this. So let me make that 0, 1, 2, 3, 4, 5, 6, 7. So here this means y is less than or equal to 3. We've already done that. There's the 3 and all the things that are smaller to it, to the left of it. And then bigger than this, 7 is less than y, means y is bigger than 7, if you remember. So these are all the things that are bigger, and I'm signifying by an open circle. And you realize it's an or because there's 2 things. It's less than 3 or it's bigger than 7. And this one would be a compound where it's both. This is less or equal to negative 2 and bigger or equal to negative 10. Let's try exercise 1. We're going to solve where is 10 minus 2x greater or equal to 4. Let's do it using a graph or a table. Let's start with a table. If I look at the left side of this expression and put it here, and I just plug in 0, let's see what values of x do we plug in to get things that are bigger than or equal to 4. So if I plug in a 0 here, I get 10. That doesn't work. Plug in a 1, I get 8. Plug in a 2, that would be 10 minus 4, which is 6. Plug in a 3, 10 minus 6, which is 4. Again, just to see that, if you want to see one. 2 times 3, which is 10 minus 6, which is the 4. Plug in a 4, you get 10 minus 8, which is 2. And then plug in a 5, you get 10 minus 10, which is 0. So we want to know, when is this bigger or equal to 4? It looks like this expression is bigger or equal to 4 here, here, here. Oh, but then it switches, doesn't it? So it looks like all the values that are less than or equal to 3. All the values that are less than or equal to 3. So that is the idea of this expression. Now we're going to be able to do this algebraically as well, but let's just look at it visually. I'm going to do it on a calculator. How would we graph that on our calculator? Well, let me get out a calculator here and show you. Oh, I lost the calculator. There it is. Okay, so what I'm going to do in my calculator is I'm going to graph y equals, so I'm going to, if you remember, oh, every time I type in it loses it. If I plug in y equals, and I'm going to plug in 10 minus 2x. So let's go ahead and do that. I guess I'm just going to have to do it. Y equals, and then let's type in a 10 minus 2, and then the x. And then remember we did zoom. I know it's going to disappear in a second, but that's okay. Then I'm going to do zoom. And I think number 6 is standard. Let's see if that's right. So let's go to zoom. Make sure, oh, no, oh, 6. Yep, 6 is standard. So I'm going to just hit 6. And there I go. And then what I'm going to do is I'm going to trace. I know I keep on losing that, but that's okay. We're going to hit trace. This was zoom. So let's go back, get that calculator again, hit trace. And let's just go to the right and see what the y is. That's the expression 10 minus 2x. You notice when x is, right, now x is 2, x is going to be 3 in a second. Right when it hits over 3, y is smaller than 4. If you want to see this a little better, you can try something else. We can try, if we go to zoom, we can try decimal. So you don't see those ugly, these will be nice decimals. Oh, yes, I don't know if that's going to work. Let's go to trace. Oh, let's go to zoom, and let's zoom out 3. I'm doing a bunch of different stuff. I want to do both. Go to trace. If it works, I'll write what I did. Yep, that works. So let's look at, so if you notice x, if we keep on going to the right, you notice how these expressions are bigger than 4. We're looking for where they're bigger than 4. All the x is less than 2. It just looks a little cleaner. Oh, let's get to 3. Right when we get to 3, oh, it skips it. It still skips it. But 2.8, you'll notice it's bigger. And then 3.2, it's a little smaller. So again, all the x is less than or equal to 3. How did I get this? I went to zoom, and I went to decimal. I think it was number 4. Let's go check that out again. Zoom, decimal, yep. And then I decided to do one more and do zoom 3 out. So then I did it again, zoom number 3. For this one, you have to press enter too. So anyway, so that's the idea. And then I just hit trace again to check it out again. Just visualize. Now, you can do this algebraically. They're going to show you that in the book. If we wanted to do this algebraically, let's do this algebraically. What we're going to do is solve like it's an equal sign. So if I solve this, I would subtract 10 from both sides, just like we did before. But there's this weird thing that's going to happen here. The weird thing is that when you multiply or divide, we're going to see this in a few again, but if you multiply or divide by a negative, what happens is that the inequality, notice how it's a less than sign, the inequality gets switched. Kind of weird, isn't it? We're going to see why. So before we do, I want to just write down the rule in the middle here. The rule is if you multiply or divide by a negative, so I divided by a negative here, you're going to reverse the direction of the inequality. So let's look at a few examples of that on a different page. Let's just go and get the blank paper out. So I'm going to solve inequalities algebraically, and I'm going to look at these two examples. This 2x is less than or equal to 6 versus negative 2x is less than or equal to negative 6. So if I pretended this is an equal sign and divided both sides by 2, I would get 3. This one, if I pretend it's an equal sign, I divide both sides by negative 2, I also get 3. Why do you switch this one and you don't? You're not going to, by the way, the first one, but you are in the second. Let's see that. So let's just look at 2x here, 1, 2, 3, 4, 5. So that would be 2, 4, 6, 8, and 10. Notice how x is less than or 6. Sorry, the value is less than or equal to 6 when x is less than or equal to 3. Versus when you have an expression negative 2x, this is negative 2, negative 4, negative 6, negative 8, and negative 10. Less than or equal to negative 6 means the larger the value, a negative value is, the smaller the number. it turns out to be the flip. That is why.